This is the solution to question 3 on the Physics 211 Practice Exam. In this question, we have a soccer player, I haven't drawn in here, kicking a soccer ball, takes a shot on goal, bounces off of the top of the goalposts. We know the goalpost is 2.4 meters tall. We know how fast and at what angle they have kicked the ball, and we need to figure out how far they are from the goal line. So what are we going to do? Well, we're going to write down position in x and y as a function of time, and see what distance puts the ball at this point. So let's go about our normal procedure. I'm going to pick the origin to be the location where the ball starts, its initial velocity. We need to decompose into x and y components. So if this is our initial velocity vector, then its x component is v naught cosine of this angle. And then its y component is v naught sine of that angle. Now, this lets us write down position in x and y as a function of time. So let's do that. So I know x of t is going to be v naught xt. All of the other terms are 0. Y of t is v naught yt minus 1/2 gt squared. Again, it starts at the origin. And I know what these are, right? I can put in the trig anytime I like. I don't have to do that now. As always, the critical part of these questions is asking the right question, to translate a thing about a physical situation, about a person kicking a soccer ball, into a question about x's and y's. So what we need to ask is, what value of d makes it such that x equals d at the same time that y equals h, question mark. So that's what I need to do. And this gives us a roadmap for doing the algebra. The first thing I need to do is find the time when y equals h. So I set that equal to h. h equals v naught y t minus 1/2 gt squared. This is a quadratic equation. So put everything on one side. I have 1/2 gt squared minus v naught y plus h equals 0. This is a quadratic equation. Oops, forgot the t here. This is a quadratic equation, so I have t equals v naught y plus or minus the square root of v naught y squared minus 2 gh all over g. And v naught y is, of course, v naught sine theta. Now, just so I'm not tapping on a calculator during this video, I already put in these numbers, figured out the times that you get, substituting in v naught sine theta here. So this gives us t equals 0.46 or 1.04 seconds. So those are the times. Now, the other thing that I wanted to do was to find what value of d x has at that time. So I just take those times and I substitute them into the x equation. So I can write, let's use this color, x of t equals v naught x multiplied by either of these values, 0.46 seconds or 1.04 seconds. And this gives us, and again, I've calculated this in advance, so I'm not tapping on my calculator during the video. This gives me a distance of 6.01 or 13.5 meters. So why do I have two solutions? You'll always get two solutions, well, almost always, when you're working with the quadratic formula. What does this mean? Well, what I've asked is, what is the time that y equals h? And it turns out there are two times when y equals h. There's this one. This is the one we want. But then there's also another time when y is equal to the same value, that one, which is not the one we want. So this value, the larger value, is what we want. And this distance is 13.5 meters. I'll notice that I used 10 for g here. You might have used 9.8 and gotten slightly different numbers. I can erase this, put this in. 13.5 meters. Now, the last part of this question says, if you use the quadratic formula, what does the other root mean? Well, sorry, part C. We just answered part C. I'm actually done. I finished faster than I thought I was. This is the answer to part D, right? The distance between the kicker and the goal line is 13.5 meters. The other value we got for the time corresponds to this moment. So this is the solution to question 3. Pretty straightforward.